Um, what shall we talk about today? Let's talk about work. Now, for a scientist, the definition of work is the force used to move something. That doesn't mean to say that if you kick your carpenter, you make him work. That's the force used to make him work. But it's the amount of force needed to accomplish something. That's work. And throughout time, we humans have been very clever, very inventive at finding ways of doing things using the least possible force, with doing the least possible work. For example, if I were to ask you, can you lift an elephant? You'd probably say no. But actually, all of us can lift an elephant if we just use the right tools. Let me talk about simple tools, things you've probably never thought about. For example, if you have some children sitting on a seesaw. This one is heavier, so he's going down. This one is lighter, so it goes up. But of course, if you were to do something like that, most of you understand that if you have something here and something there, because this one is farther away, it has a bigger effect. So let's talk a little bit today about force and how things work. When you use something like this, it's called a fulcrum. F-U-L-C-R-U-M, a fulcrum. If, for example, you were to, let's take the seesaw again. If you were to balance a piece of wood on a fulcrum like that, and it was exactly the same distance, from there to there was the same as from there to there was the same distance, then it would balance. However, if you take the same one again, the same distance, more or less, and you put a weight on here, it's going to go down. I mean, you all understand that. But really, to measure the force, what you do is you measure this times the distance. So if you put, for example, let's say this is 3. From there to there is 3. And from there to there is only 1. So here is 1, here is 3, the distance there. Do you get me? If you put something that weighs 5, let's say 5 pounds there, to measure that force, you take that weight times this distance, 5 times 1 equals 5. Now this is 3. So if you were to put something here that only weighed 2, not 5, but 2, you measure this by the distance, so 2 times 3 is 6. So this is bigger than that. 6 is bigger than 5. And what happens? It goes down like that. So the 2 will lift the 5 because it's further away. So that's how a seesaw works. Let's have a look at another sort. If, for example, you have the fulcrum there, and you have it like that, and you have something here, let's call it, and you apply a force there, that's a different sort of force, but it's the same thing. You measure this, let's call that A, you measure this, so A times B will tell you what the force there is. Let's call this C, and this is D. C times D is another force. And an example of something like this is a nutcracker. If you want to crack nuts, it looks like that. You know, you have this and you apply this force and it cracks the nut. Another way of applying force is something like this. If you have how can I draw it? If you had a pair of tweezers like that, you know, to take the hairs out of your nose or something like that. There you have the fulcrum. Here is where you're applying the force. You hold the tweezers like that. You hold the tweezers there and there. And that's where you apply the force, and then here you pick out the hairs with your nose. So all these little things are ways that we use levers and the seesaw technique. I'll talk more about that another day.